Hello, this is the exam review for exam number 1 for intermediate algebra. So let's go ahead and jump right in. We have this equation here, 9x minus 14 equals 31. And the process for solving this equation is to isolate x. So I want to get x by itself. The first thing we'll get rid of is the minus 14. We'll cancel that out by adding 14. If we do that to the left-hand side, we have to do the same thing to the right-hand side. So on the left-hand side, we'll end up with just 9x because the 14s are going to cancel out. And then on the right-hand side, we'll get 31 plus 14, which is going to be 45. And then to get x by itself, we'll divide by 9 on both sides, and we'll get x is equal to 5. And that's the solution. So we will use option A here to type our answer into Math Excel, and in the box there we would type in 5. All right, the next equation we're going to look at is fractions. So it's same kind of problem, but we have a bunch of fractions to deal with. And so the process for dealing with these fractions is just to get rid of them, which is a nice thing to do. And the way you get rid of all the fractions is you multiply the common denominator to both sides. The common denominator here for 7 and 14 would be 14. So I'm going to multiply 14 to both sides. That will get distributed, so it'll get multiplied to each term. So it gets multiplied here, it gets multiplied here, and it gets multiplied here. When the 14 gets multiplied to a fraction, you might find it helpful to think of 14 as a fraction also. So we can think of that as 14 over 1. And what's going to happen is the 14 will get divided by whatever the denominator is, and then multiplied by whatever the numerator is. So if we take 14, divide it by 7, that gives me 2. Right, 14 divided by 7 is 2, and then we multiply by 3. 2 times 3 is going to be 6, and so we'll just get 6 from that. The x gets copied down, so be sure not to forget about that. Put a plus sign. For the next term, we'll get 14 divided by 14, which is 1. 1 times 6 is going to be 6. Again, there's another x here, so we'll copy that down as well. Equal sign. And the same thing happens here. You can think of it as the 14s just cancel out, but you could also do it the same way we did the last one. 14 divided by 14 is 1. 1 times 48 will be 48. Right, and now that the fractions are out of our hair, we can solve this equation, in the usual way. The first thing we'll do is combine like terms. So we have 6x plus 6x, which is 12x, equals 48. And then we can get x by itself by dividing 12 on both sides, and we'll get x is equal to 4. All right, so that is the solution. Again, choose option A, type in 4. Let's take a look at the next one. So here we have negative 4 plus 16x equals 16x minus negative 4. So the first thing I do is focus on getting all of my x's to one side of the equation. So I want to get rid of it from the right-hand side. I'll do that by subtracting 16x to cancel it out. If I do that to the right-hand side, I have to do the same thing to the left-hand side, and something unusual happens. The x also gets canceled out from the left-hand side. So not that we were trying to accomplish that, but it just happens that way. So on the left-hand side, what we're going to have left over is negative 4. On the right-hand side, these will cancel out, and what we're going to have left over is a negative 4. Right. So we'll have negative 4 left over on the left-hand side and the right-hand side. So whenever this happens, whenever you have a variable that completely cancels out of your equation, then you have a special outcome. It's not going to be the usual case where, sorry, we just got a kitten and it's right here beside me, and it picks this time to start biting at my feet. So, all right, so whenever the variable cancels out of your equation completely, it's going to be a special case. Option A is not the option we're going to choose this time. It's either going to be B or C. The solution's all real numbers, or there is no solution at all. The way we determine which one of those to choose is by looking at what results after the variable gets canceled out. So here we see that we get negative 4 equals negative 4, which is a true statement. And if you end up with a true statement, then your conclusion should be all real numbers. If this had ended up being false, if, for example, I ended up getting negative 4 equals negative 5, well, that would be false. And in that case, we would say there's no solution. All right, so that's how you'll decide which one it's going to be. So if your variable completely disappears from your equation, it's going to be one of these two special cases, and this is how you know which one to choose. So we're going to choose B in this case since it came out true. All right, whoops. All right. Okay. Let's look at the next example. All right, so another equation, same idea. We want to get x by itself on one side of the equation. To get started with that process, we can't isolate x while it's stuck in the parentheses. So we need to get x out of the parentheses by distributing. So we'll go ahead and distribute the 7 into the parentheses here. So we'll get 21x plus 42 equals, we'll have the 11 here. And there's no number for me to distribute that you can see anyways, but we do still have to distribute this minus sign into the parentheses. Now, technically, it's probably not, mathematically proper to say that. What we're really distributing is a -1, right? There's an invisible 1 there. So distribute -1 into the parentheses, you'll end up with -x minus 2 as a result. So both of these terms will change sign because of that minus sign. All right, now that the parentheses are out of the way, we'll go ahead and simplify. So I'm going to copy the left-hand side down, 21x plus 42. Sorry, I said the answer. 11 minus 2 will be 9. And then I'll copy down the minus x. And then from here, we will work to get x on one side, everything else to the other side. So I will add the x to cancel it out from the right-hand side. So I end up with 22x plus 42 equals 9. Then I will subtract 42 to get the numbers to the right-hand side. And I'm going to end up with 22x equals -33. The last step is to, well, I guess really the next to last step. This is the last step to get x by itself, but we have one more thing we're going to have to do after this. All right, so divide 22 on both sides to get x by itself. So we'll get x equals -33 over 22. And the last thing you want to do, which you always should try to do when you have an answer that's a fraction, is reduce the fraction. And this one, the numbers are not quite something that you're probably familiar with. Maybe it's a little bit unusual for you, but this actually can be reduced by dividing an 11 from the top and bottom. So the numbers are a little bit unconventional, I guess, but can still be reduced. So we have to be on the lookout for that. And it reduces to -3/2. All right, let's take a look at the next example. All right, so here we have a formula, which is an equation that has multiple variables, and we're being asked to solve for one of those particular variables. So we're being asked to solve for J. It's currently solved for C, right? The variable it's solved for is the variable that's by itself. So right now it's solved for C. We would like to have it solved for J, which means we want J to be by itself. The thing you have to realize here is you can't treat every variable like it's special. So the one that you're trying to solve for is your special variable. So we're trying to solve for J, so that's the one I'm going to treat special. All the other variables I'm going to treat the same way I would treat numbers. Right? So I have this variable n being multiplied to J. What would I do with a number being multiplied to the variable I'm trying to solve for? I would divide by that number. I'm going to do the same thing with this variable. So to get rid of this n, I'm going to divide by it on both sides of the equation to cancel it out. And so the n's are going to cancel out. So I end up with, on the left-hand side, c over n. And on the right-hand side, I'll have j by itself. And so it's now solved for j. So that's all there is to that. You said divide by n to get j by itself. And that was all you had to do. All right, let's take a look at the next one. This one's going to be a little bit more work. We have r equals 5g plus 5u. Right? It's currently solved for r, but we would like to have it solved for g. So I want to get g by itself. I'm going to treat all the other variables as if they're just numbers. And the first thing I would do if these were all numbers is I would get rid of this number here first. Right? So to cancel out adding plus 5u, I will cancel it out by subtracting 5u. Right? Subtraction cancels out addition. And that's the first thing I want to get rid of there. On the left-hand side, things don't really simplify very nicely for us. That happens with formulas. So we just have to write these out side by side. R minus 5u. On the right-hand side, all we're going to have left is 5g. And to get g by itself, we'll divide by 5. It's not even a variable anymore. So now when you divide both sides of the equation, you have to divide the entire right-hand side and the entire left-hand side. Right, so the 5s are going to cancel out here. Sorry, I kind of missed the mark. And so I'll get g by itself. And this fraction bar goes all the way across. So we're going to have r minus 5u. The whole thing will be divided by 5. And we can just leave it like that. You could also write it like this, and so depending on how you go about the problem, you might come up with the answer in this form. It'll be r over 5 minus u equals g, and that would be the same thing, and Math Excel would accept this as the correct answer as well. So you can just leave it like this, but if you did things a little bit differently and came up with this, that's going to be okay as well. All right, let's take a look at this last one. Now this is going to be the most difficult one. We have w equals n plus nrx. It's currently solved for w, but we're being asked to solve this formula for n instead. Now, a common mistake students will make with this problem is they'll say, okay, I'm going to solve this for n by getting this n by itself. I'll subtract the nrx to the other side, and they will come up with this as their answer. W minus nrx equals n. And while this part looks good, that's the way you want the answer to look, n equals something, it's not really solved for n because you still have an n on the left-hand side. So you didn't really isolate that variable because it's still in two different places. So what we need to do, so this isn't going to work, what we need to do is rewrite this equation so there's only one n instead of two n's. And the trick for doing that is to do something that we haven't talked about yet in this class because it's just chapter 1 after all. But we're going to talk about later in chapter 4. But it's something you've probably done before. It's called factoring. And so what we have to do here is factor out the common factor, which is n. N is a factor in the first term, n is a factor in the second term. We are going to factor it out. So this is called factoring out the common factor. You might also think of it as undistributing. So it's just like we distribute things into a parentheses, we can bring things outside of parentheses. We can undistribute it. As long as it's common to both terms, you can undistribute it. So that's what we're doing here. So it's using the distributive property, a plus bx. Right, so this is the formula for the distributive property. You can distribute the a into the parentheses and you get ab plus ac. But we're using it backwards. Right? These rules work in both directions. So if you start with this, AB plus AC, the distributive property tells me I can rewrite that as A times B plus C. And what's going on there is A is common to both of these terms, so we are taking it back out. We are undistributing it, writing it one time in front of the parentheses. And then in the parentheses, we write what's left over. We have a B left over here. We have a C left over here. So that's what we're going to be doing with n. Right? We're going to take the n away from both of these terms, write it one time in front, and then in a set of parentheses, we're going to write what's left over. Another mistake students likely make on this problem is thinking all you have left over is the rx. There's a little bit more to it than that. You have something left over from this term as well. It's hidden from us, but we talked about it a little bit earlier on one of the earlier examples. There's an invisible 1 here. So when you take the n away, the 1 will still be left behind. So we're going to have a 1 here plus rx. All right, so that's how that's going to look. Take the n away, write it one time outside parentheses, and then in the parentheses, we write what's left over. All right, now we still have the left-hand side here, which is w equals this expression. And now that we have just the one n, we can isolate it by getting rid of the parentheses that's here. It's being multiplied by this parentheses, so to cancel it out, we'll divide by it. And we'll divide by 1 plus rx on both sides. That cancels out the parentheses. We get n by itself, and on the left-hand side, we'll have w over 1 plus rx. And that's now solved for n. It's isolated. It doesn't exist on both sides of the equation. So that's what your answer should be. All right, next problem. Looks like we're going to have some word problems here. The perimeter of a playing field for a certain sport is 326 feet. The field is a rectangle, and the length is 47 feet longer than the width. So find the dimensions. All right, so it's a rectangle, so anytime you're dealing with a geometric shape in a word problem, it's really beneficial to actually draw that shape out. And so a rectangle has a width and it has a length, and we're being told something about the length here. The length is 47 feet longer than the width. So we have some information about the length. We have no information whatsoever about the width. So my advice to students with these word problems is always let your variable, let x be the one that you know the least about. So I'm going to let x represent the width because I'm not told anything about the width. So x will be the width. And then the length, I use my clue to represent that. It's 47 feet longer than the width, which is x. So 47 feet longer than x can be written as x plus 47. Right, it's 47 feet longer than whatever the width is. Now, with a rectangle, there's 4 sides to it, right? So we're just labeling these 2 sides, which is very common because it's understood that the opposite side also has the same measure, right? So if the left-hand side has length or, measure x, the right-hand side would also have a measure of x. If the top side has a measure of x plus 47, then the bottom side will also have a measure of x plus 47. That's important because perimeter is the distance around the entire object. So we have to consider all 4 sides when we're looking at the perimeter. So the perimeter is 326 feet. So if I add up all 4 sides of this rectangle, that's what it should add up to. And that's how I'm going to get my equation. So I'm going to add up all 4 sides, x plus 47 plus another x plus 47. And that should add up to the perimeter, which is 326 feet. Once you have your equation, you solve your equation to find x, and then once you have x, you can answer all the questions in the problem. Right. So we have 1, 2, 3, 4 x's plus 47 plus 47, which is going to be 94, equals 326. And then we're going to solve this for x just like we solved the equations we saw earlier. Subtract 94 from both sides first. So we'll get 4x is equal to 232, I believe, right? So the way I'm not that great at doing calculations in my head, but the way I'm trying to do this without a calculator is subtract 100. That'd get me down to 226, but I really want to subtract by 6 less than that. So my answer should be 6 bigger than 226, which will be 232, I believe. So hopefully I'm right. We'll find out here if this divides evenly. That's probably a good sign. So we'll divide by 4 on both sides. 4 goes into 23 5 times. The remainder would be 3. Bring down the 2. 4 goes into 32 8 times. So it works out nice. I believe that's probably correct. So x is 58. X is the width. So ask me for the width first. That's going to be 58. The drop-down menu here is going to have the units. The unit should be the same as whatever the perimeter is. So this will be 58 feet. And then to find the length, we'll take this information and plug it in here to find the length. So it'll be x plus 47. That's going to be 58 plus 47 because x is 58. And so that's going to give me 5. That's going to be 105. All right. And so that would be the length. And that's what I would type in here, 105. And again, this will be in feet. All right. Okay, so let's look at the next problem. It's probably going to be another word problem. At a certain real estate firm, realtors selling homes receive a commission of 7% for the first $150,000 of the selling price of the house, and 3% for any amount exceeding $150,000. A realtor for the firm received $13,260 for selling a house. What was its selling price? All right, so what I would recommend doing for this kind of a word problem is writing out in words what the equation should look like, how the different parts of the problem fit together in an equation. But don't use variables, don't even bother using numbers necessarily. Just use words to fit it all together so that it still makes sense and it's not too abstract, right? So this realtor, I'm trying to think of the right word here, is going to get 7% of the first $150,000 of the selling price of the house. So 7% of that first $150,000. And in addition to that, so plus 3% of any amount over $150,000. And that's going to equal the commission that they earn. All right. So just using words now, we know the commission, right? It's 13,260. But for now, I'm just going to use words to represent it. So this is the way the realtor's commission is calculated. 7% of the first 150,000 plus another 3% of any amount over 150,000, right? So again, nothing abstract about that, and it kind of structures it as an equation, but we're still using words, so everything still is, understandable. There's no algebra here, nothing abstract about it. Now the commission, as I already mentioned, we know what the commission is, so we don't need a variable to represent that. That value is just given to us. It's $13,260. Right. We also don't need a variable here because there's nothing unknown. You get a full 7%, which is going to be 0.07, that's how we write 7%, of that full $150,000. The only iffy part about this is if the house sold for less than $150,000, which could be the case. I've never seen that happen though with this problem. So I think you can just assume it'll be over that amount. If it ends up being wrong, if it actually is less than 150,000, then when we solve this equation, we'll get a negative number and we can figure it out from there. But that never happens. So I don't think you have to worry about that. Plus 3%, 0.03, of the amount over 150,000. And that's the part we don't know. How much more did this house sell for than 150,000? It's not given to us. So here's where we need our variable. Now, if you look on Math Excel or My Math Lab or whatever you might be using to get help on this question, they actually set it up in a different way than I do. So I try to keep things simple, especially when I'm trying to set up an equation. So I'm just going to let X represent these words here. X is going to represent the amount that the house sold for over 150,000. So X is not the selling price of the house. It's the selling price of the house that's in excess of $150,000, right? However much more it was than 150,000, that's what X is representing. And that keeps the equation nice and simple, right? So now we need to solve this equation for X. And now I probably will need a calculator. Let me see if I can find one real quick. As a math teacher, you usually have calculators handy at all times. So here's one right here. We have 0.07 times 150,000. And that gives me 105. Let me change color. Okay, I already did. It's going to be 100. Sorry, I'm saying the wrong number. 10,500. Right. Plus 0.03x equals 13,260. Right. So now I'm going to solve for x by subtracting the 10,500 to the other side. And I'll get 0.03x. Right, this is going to cancel out. And so I'll get 13,260 minus the 10,500 leaves me with, I probably could have done this in my head if I tried, but using my calculator, $2,760. And then we'll divide by 0.03, which is going to make this a fairly big number here. So we'll divide by 0.03 and we'll get 92,000. Right. So we get 92,000 as our value for X. Now, we're being asked for how much the house sold for, but X is not the full, complete selling price of the house, right? The way I set up my equation, X was only representing the amount that went over 150,000. So to get the final selling price of the house, I have to take the 92,000 that I just found and add it back to the base of 150,000, right? That's sort of the cutoff where I stopped, right? So X was not representing that 150,000. X was only representing the amount over 150,000. So to get the final price of the house, I have to add that 150,000 back in since I was leaving it out in my representation of X, right? So X left out this 150,000. So now we have to add it back in to get the final selling price of the house. So hopefully that made sense. So let's find out what that would be. So using my calculator again, I get $242,000, right? $242,000. So quite a Nice value for a house. All right. Let's look at the next one. So I think we probably have one more word problem here. All right. A carpet cleaner charges $75 to clean the first 190 square feet of carpet. There is an additional charge of 25 cents per square foot for any footage that exceeds 190 square feet and $1.40 per step for any carpeting on a staircase. A customer's cleaning bill was $253.95. This included the cleaning of a staircase with 13 steps. In addition to the staircase, how many square feet of carpet did the customer have cleaned? So I know that was a lot of information to read through, and of course you can't sit there and crunch the numbers as you're being thrown all these numbers, right? You can't possibly make sense of everything all at once with all the numbers you're having to deal with. But I still think it's valuable to just read the problem completely, even without even writing anything down, just to get a sense of what's going on. Now let's go back through the problem, right? There's a $75 fee to clean the first 190 square feet, right? That's just to get started with the cleaning, right? Then there's an additional charge, so we'll put a plus sign, additional charge of 25 cents, 0.25, per square foot over the first 190 square feet. So it's very similar to the last problem, right? And I'm going to handle it in a very similar way. And in addition to that, $1.40, right, per step. And that's going to equal the total bill, right? So that's how this company decides how much to charge somebody. This is the formula that they use. So again, we don't need a variable for the $75 because we know that it's $75. We don't need a variable for the steps because we're told how many steps there are. It's $1.40 per step, and there will be 13 steps altogether, right? So they'll pay $1.40 for each of those steps. So to determine the total amount they have to pay for the steps, you multiply $1.40 times the number of steps that they have. We don't need a variable for the bill because we know how much their bill was. It was $253.95. So the only thing we don't know is this. It's 25 cents per square foot for the square footage over 190. We don't know how much over 190 it was, so I'm going to use X to represent that. Now keep in mind, X is leaving out that first 190 square feet. So if I want to get the total square footage, I'll have to add that 190 back in at the end of the problem. All right, so that's going to be my equation. So we'll have 75 plus 0.25x, let's put those closer together, plus, using my calculator again, we have $1.40 times 13. It's going to be $18.20 equals $253.95. Now, my usual habit is not to add or subtract things on both sides of the equation until everything's been simplified as much as possible. So I'm going to go ahead and add these two together, 75 plus $18.20. And so I'm going to get 0.25x, that just gets copied down, plus $93.20 equals the $253.95. Now I'm ready to move things around, so we're going to try to get x by itself. The first thing that's got to go is the $93.20, so I'll subtract that to the other side, and we're going to get 0.25x equals, find out here, $253.95, $160.75, and then we divide by 0.25 on both sides. And we are going to get, we'll just write it over here, x equals 643. So if that's what you type into Math Excel as your answer, it's not going to get counted correctly. And this is very risky because especially for my online class, it's graded based on whether you have the right answer or not. So even if you did all of this work correctly, you type in the wrong answer there, it's just going to say it's 0 points. So be very careful to catch these details, right? X is representing the amount of square feet over 190 square feet. So X does not include that initial 190 square feet, so we need to add it back in. So we're going to add back in that 190, and we're going to get 833, right? So the total square footage is 833 square feet. That's what you want to type in the Math Excel. All right. Let's move on to some non-word problems here. So inequalities. So you solve these the same way you solve equations. So we're just going to do the same thing we did before with the equations. We're going to get x by itself. So to do that, I'll subtract 2 from both sides, get 6x is less than 20, and then I'll divide by 6 on both sides, and I'll get x is less than 3. And that's all there is to that. So I find the symbol over here that matches up to that. It's the less than symbol. It's this one right here, so I will choose option A, and I'll type 3 into the box. All right, I'm going to do the same thing on this one, solve it just like we would solve an equation, except there's going to be one extra thing we have to be careful about here. So first, I will start by getting y to one side, so I'll subtract the 9y to cancel it out from the right-hand side. On the left-hand side, I get negative 2y minus 3 is less than negative 4. All right. Then I will add 3 to both sides. I get negative 2y is less than negative 1. And then I divide by negative 2 on both sides. I'll get y on the left-hand side. The negatives will cancel out, so I'll get positive 1/2 on the right-hand side. But what I should get as my symbol here in the middle is a greater than symbol. If you divide by a negative on both sides, you have to flip the symbol around the other way. And so this is the correct answer. Happens to be option A again. That isn't always going to be the case, so don't just assume it's always A. Just coincidentally happened to be A for us both of these times. All right, let's take a look at the next example. All right. Here we want to write interval notation for the graph. So interval notation looks something like this, where this means all the numbers between A and B. All right, so we want to write what's shaded in here using that notation. And what's being shaded in are all the numbers between 2, that's the very end on the left-hand side, and on the right-hand side, there really is no end. It keeps going forever. So the symbol we use to represent that is infinity, right? So this would be infinity over here. So my interval notation, the important thing you have to remember about this is it goes from smallest to largest. So 1, 5 makes sense. That's all the numbers between 1 and 5. 5, 1 doesn't make sense. It is not proper interval notation. It has to go from smallest to largest. So smallest would be the number furthest to the left, which is 2, largest is the number furthest to the right, which is infinity, which is to say there isn't a largest one. Use the same symbol in the graph as your endpoint for your interval notation. So if it's brackets in the graph, it's brackets for the interval as well. And that means the 2 is being included here. On the right-hand side, you look for the symbol, but infinity, you never reach it, so you never get to see what the symbol is on that. But the rule of thumb for infinity is you always use a parentheses because you can't contain infinity with a bracket. It keeps going forever. So we always use parentheses on infinity. So that's what the interval looks like, and that's going to be option D. All right. All right, so solve this. We're going to divide by 5 on both sides. We'll get x. This time we do not flip the symbol around the other way because we didn't divide by a negative. We only divided by 5. So this is still going to be greater than or equal to, and then 15 divided by 5 is 3. So we get this. That's going to be option C. And then the graph that matches this, well, what we're looking for are all the numbers that are bigger than 3. So I find 3 on my real number line. The numbers that are bigger than 3 are going to be to the right of 3. So it has to either be A or B. And then if we have an equals to, that means we want to include the 3, right? It's okay for x to equal 3. And what includes the 3 is the bracket symbol. If there was no equals to, then we would use the parentheses to show we're not including the 3. So B would be the correct graph here. It's the numbers bigger than 3, shading to the right of 3. These are the numbers bigger than 3. And then bracket on the 3 because of the equals to. All right. Intersection means we're looking for the numbers that these two sets share in common. So you're looking for the overlap or what's shared in common only. And this is sort of a trick question because these sets share nothing in common. They have no numbers common between them, so the intersection, the commonality between them is going to be nothing. It's going to be the empty set, right, which is this symbol here. So a 0 with a line through it. So that would be the answer in this case. The other problem you might see in this slot is the union problem. And if this was a union, let's go ahead and just do the same problem with a union. So this is the first set, this is the second set. A union means you want to join everything together. So you don't look for what they share in common, you just keep everything that's there, right? And you join it together into one set. So I'm going to make one set out of these two, joining them all together, putting all the numbers into one big set. So I'm going to have 2, I'll have 4, I'll have 5, 6, 7, 9, and 10. Right? And so that's what the union would be. So the union is joined together into one big set. Intersection symbol is just what's shared in common. All right. So now we're going to have some compound inequalities, and the way we're going to handle these is solve each of them for x. So I'm going to solve the first one for x by subtracting 5 from both sides to get started. So I'll have negative 21 is less than or equal to 3x, and then divide by 3. So I have negative 7 is less than or equal to x. We'll do the same thing here, subtract 5 from both sides. Hope I didn't say that the first time. And so we'll get 3x is less than 6, and then we'll divide by 3. We get x is less than 2. Right. Now, for an and, you can join these x's together. So it's kind of like merging these two statements together. I'm going to take, it's like, and they line up where these x's are. So I'm going to merge this statement with this statement. The x is where they get merged together, and there will only be one x. And then to the left of x, we're going to have this symbol with the negative 7 on the other side. And to the right of x, we're going to have this symbol with the 2 on the other side of that. So I'm merging these two statements together into one statement, and I do that by lining the x's up together. You can only do that when it's an and. If it's not an and, you cannot write it like this. Right, so this is what we end up getting. So the option we want to choose over here is option A, because it matches the symbols. Less than or equal to for the first one, just less than for the second one. And we'll type the numbers in here, negative 7 into this box, 2 into this box. And then the correct graph is just shading between these two numbers. So I want the graph that shades between negative 7 and 2, which would be either A or C. They both do that. But I need to choose the graph that's using the right symbols on the endpoints. Again, if there's an equals to like we have here, we want to use the bracket. If there's no equals to like we have here, we use the parentheses. And so option A is the one that has the right symbols for that. Right, brackets on the negative 7, parentheses on the 2. All right. This is another compound inequality that's already joined together. So the previous one we did got split up, and we had to join it back together ourselves. This one, it's already joined together. And the process for dealing with this kind of compound inequality is to solve for y in the middle, right? So get y by itself in the middle. And whatever the rule is, whatever you do to the middle, you have to do to both of the outsides. So to get y by itself, just like solving an equation, the first thing I would do here is subtract 11. But whatever I do to the middle, I have to do to both the left-hand side and the right-hand side. So to all three parts, I am subtracting 11. And so I'll get 5 minus 11, which is negative 6, less than 2y, the 11s here cancel out, less than or equal to 2. All right. Then to get y by itself, I will divide by 2. If I divide by 2 in the middle, I have to divide by 2 on the left-hand side and on the right-hand side, right? Both outsides. And so we're going to get negative 3 is less than y, which is less than or equal to 1, right? The 2's here are going to cancel out, but 2 divided by 2 is still going to leave a 1 behind. All right, so this will be my answer. Looking over here at our options, we want to choose option C, right? Has the less than symbol first, the less than or equal to symbol second, so it's this one here. So negative 3 in this box, 1 in this box. All right. This time we have an or, so it's a compound inequality these cannot be written together into a single statement. You can't merge the x's together like we did a couple of examples ago. They will just stay separate with an or between them, usually. Usually that's what's going to happen. All right, so, but the process that we're going to use is the same as previously. Solve each of these for x. So the first thing I'll do is add 2 to both sides here. And I'm going to get, I'll start over here, negative 2x is less than negative 16, right? Because the 2's here are going to cancel, the 2's are going to cancel out. And then divide by negative 2 on both sides. And don't forget our special rule. If we divide by a negative on both sides, the symbol has to get flipped around the other way. So we're going to get x is greater than 8. Right, then we're going to have the or. We're going to do the same thing over here. We'll add 2 to both sides. And so we're going to get negative 2x is greater than 20. Right? And so the 2's here cancel out. And then we'll divide by negative 2 on both sides. And we'll get x, again, dividing by negative on both sides. We flip the symbol around the other way. X is less than negative 10. And so this is our answer. And so we want to type that in over here. So which option do we want to choose? Well, neither one of these has an equals to on it. So the only one that matches up to that is C, right? Where both symbols are missing the equals to. But do not type 8 into the first box here because that doesn't match up to that symbol, right? We have a greater than symbol here. 8 needs to go with the greater than symbol, which is this one right here. So 8 goes into this box, and then negative 10 goes with the less than symbol. And so negative 10 should go into this box here. So be careful about that. Sometimes the numbers you get in your answer won't be in the right order for the way it needs to get typed into Math Excel. And so really, mathematically, it doesn't matter which order these two inequalities are written in, but Math Excel is making that choice for us. They're putting the less than first, they're putting the greater than second, so we have to adjust to that. So be ready for that. All right. Now we're going to be solving some absolute value equations and inequalities. The way you solve an absolute value equation is you really can't solve the equation while it still has the absolute value. So what we're going to do is rewrite it as two ordinary equations without absolute value. And the way you're going to get your two ordinary equations, the first one should be exactly the same as the original, but without the absolute value. So I'm going to rewrite the same equation I had to start with, 4x minus 5 equals 6, but I'm going to leave the absolute value off of that. The second equation, what we're going to do is make one change. The left-hand side will stay the same, but the right-hand side will be negative 6. Right? So we're going to write two ordinary equations instead of dealing with the absolute value equation. The first equation is the same as the original. The second equation, the left-hand side stays the same, but we take the negative of the right-hand side. And by doing this, we're going to find the solutions to this equation here. But we're doing it in a way where we don't have to deal with the absolute value. So now we can solve each of these for x. I'll start by adding 5 to both sides, and that's what I'm going to do for both equations. Right. So we'll get 4x equals 11 for the first equation. We'll get 4x equals negative 1 for the second equation. Then we'll divide by 4 to get x by itself. We'll do that in both cases. So for the first equation, we get x equals 11 over 4. For the second equation, we get x equals negative 1/4. And these are both valid solutions to this equation. What allows me to do this is the fact that the absolute value of 6 is one way we can get 6, but also the absolute value of negative 6 is another way we can get 6. So there's two ways to make this give me a 6. Either this has to come out equal to 6, or it has to come out equal to negative 6. When does this equal 6? That's why we set up this equation, to find out. So I'm not going to guess at what x is supposed to equal. I'm going to get the equation to tell me what x is equal to. And when does this equal negative 6? I'm not sure. So I'm going to take this expression, set it equal to negative 6 to find out. So that's why we're setting up these two equations here. Again, you don't need to know the background information for that. If you don't want to, I mean, I think it's helpful to know why this works, but if you're just looking for the minimum amount you need to know to get the answer right, this is what you need to know. Set up two equations. The first is an exact copy of the original. The second one, just change the sign of the right-hand side, and you will get your answers that way. All right, so for this equation, we're going to do the same thing that we did in the last example, but one thing you need to know about the absolute value is that process doesn't work unless the absolute value is by itself. So we got to get this part by itself first, then we'll split it up into two separate equations and get our two solutions that way. So the first thing I need to do is add 5 to both sides, Add 5 to both sides to cancel out the minus 5, and we'll get the absolute value of 5x is equal to 40. Then we can use the process that we used in the last example. We're going to split this up into two ordinary equations. The first equation will be exactly the same as the original, but without the absolute value. The second equation will change the sign of the right-hand side only. That's the only change you need to make. So we'll make it a negative 40 instead of a positive 40. Then we'll solve each equation for x. So we'll divide by 5 on both sides. We'll do the same thing in both cases. So we'll get x is equal to 8 from the first equation, and x is equal to negative 8 for the second equation. All right. Then we're going to have a couple of absolute value inequalities. These are going to follow a fairly similar trajectory. Now I'm going to do this a little bit different than Math Excel does, but I'm doing it for consistency's sake. That way you can approach these problems the same way regardless. So this will have a very similar flavor as the equations. You're going to get the absolute value by itself first, which this one already is by itself. You're going to split it up into two ordinary inequalities. The first one will be exactly the same as the original. 7x minus 9 is less than or equal to 16. The second one, the left-hand side stays the same, but we're going to take the negative of the right-hand side, just like we did for the equations, but we have to make one additional change beyond that, which is flipping the symbol around the other way. So this is a less than symbol. For the second inequality only, it gets flipped around to become a greater than symbol. All right, so that's how you're going to set up your two inequalities. And then one more thing you have to know, so there's a couple of extra details you have to remember for these, is that if it starts off as a less than, if we have absolute value is less than something, that's going to translate to an and compound inequality. Right now, this video is running kind of long, so I'm not going to go into the details of why that happens, but there is a reason mathematically for why that has to be the case. You just have to remember it. If it's a less than, it becomes an and. Now that we have this compound inequality, we'll solve it the same way we solved the compound inequalities earlier. We'll solve each of these for x. So I'm going to add 9 to both sides. Again, we're going to do the same thing in both cases, so let's just take care of that now. So we'll get 7x is less than or equal to 25. Here we're going to get 7x is greater than or equal to negative 7. And then we are going to divide by 7 on both sides. And we'll do the same thing here. And we're going to get x is less than or equal to 25 over 7. And our second inequality is going to be x is greater than or equal to negative 1. And again, this is still an and. And so what we need to do is like we did earlier, we're going to, because it's an and, we can do this, and we have to because Math Excel is requiring the answer to be written this way, is we can merge these two together. So again, the x's are going to merge together, but it's difficult because the x's are on the same side of the inequality. So what I'm going to do is take this one, and I'm going to flip it around the other way when I put it over here. So I'm going to put the negative 1 on the left-hand side. I'll put the x on the right-hand side, so we're going to flip this around. And it turns out that when you flip an inequality around, the symbol has to get flipped around with it. So I'm doing a complete 180 with this expression, flipping the whole thing around. So the symbol gets flipped around also, and it becomes a less than or equal to when it gets flipped around. So this would be the same as this. And now I'm going to merge these two x's together. So my statement's going to look like this. I'll have just one x in the middle. We'll have this notation on the left-hand side, less than or equal to, with a negative 1 on the other side of that. And we'll have this notation on the right-hand side, less than or equal to, with a 25 over 7 on the other side of that. So this is what my final answer should look like. Because of the equals to, we should choose option D. We'll type negative 1 into the first box, 25 over 7 into the second box. All right, so I think this is the last problem. So let's take a look at this one. It's going to follow a very similar trajectory, but the details are going to be a little bit different. So again, Make sure you get the absolute value by itself first, which it already is. Then you're going to split it up, just like we did for the equations. 1 minus 8x greater than 4 will be our first inequality. All I did was copy that down, but without the absolute value. My second inequality will be 1 minus 8x. That part stays the same. But I'm going to flip the symbol around so it becomes a less than, change the sign of the right-hand side so we get negative 4. This time, because this started off as a greater than, right? We have absolute value is greater than something. This compound inequality actually becomes an or instead of an and. So we don't have to merge these two together. They will stay separate. But I still need to solve each of them for x. So I'll start by subtracting 1 from both sides. I get negative 8x is greater than 3. Divide by negative 8 on both sides. And we'll get x is, because we divided by negative on both sides, less than negative 3/8. Right, positive divided by negative will make that negative. But the symbol flips around because we divided by negative. Same steps over here. Should have did it at the same time. Subtract 1 from both sides, we get negative 8x is less than negative 5. Divide by negative 8 on both sides, and we'll get x is, flip the symbol around, and we'll get positive 5/8 because a negative divided by negative is positive. And again, this is still going to be an or, and so this will be my final answer. Let me try that again. All right, oh, stay up. Okay. All right. And so now we need to type this into Math Excel's formatting. Again, it's an or, so it has to either be A or D. And because there's no equals to, it has to be option D. Make sure the symbol matches up to the number that you're typing in, right? So the negative 3/8 goes with the less than symbol, so that's going to be this one here, right? So this time the numbers will go in the order that we have them. Greater than symbol goes with the 5/8. And that'll be my final answer, and I believe that was the last problem. So good luck with exam number 1. If you have any questions and I'm your teacher, please feel free to contact me and I will answer any questions that you have. Thank you for watching.